again, I just had to like take a quick nap and study and do some assignments. But other than that, I did some progress on like the API. I gotta do something. What's left to do is refactor the fetch operations and fetch implementation to the new fetch implementation and load the data with the new method of loading data, which is type safe. Damn. my hat or whatever. I'm just fucking. Damn. Okay. No more. And I believe the only thing left is to just make things good. Um, by good I mean utilization of like this sort of structure, utilizing a next dynamic function to systematically decide whether or not the page will be loaded dynamically or not, utilizing SSR or not. So that's better. And proper folder structure for each individual route. That's about it. like the prompt now. What's this? I like the prompt now. I gotta fix these. I do. Identifying when a view tag event file. Yeah. Probably because. Okay. So it should be here, and that should just define it here. Should be within this or whatever. Hold on. Nice. Aren't these already? Let me just call this out. Yeah, they're not. Anyways. Yeah. Hold on. Do I already have like context for this? Yeah. Let me just make something really quickly. CCC info global events on all events of the following methods. Dedicated events. Yeah, anyways. Let's make this quick script and just give it to AI. Oh. I didn't select the right thing. Hashtag, or these, that's not good. Content section. At DLDT, DT includes ID, has ID, has attribute ID. Okay. DLDT, DLDT, DL, DLDT has ID. Or whatever that is, I don't know. Has ID and then DT and then individualistically I will choose section which is just include this and then content section, reference layout. Page layout and reference layout. Then just do div. Then class reference layout content main. Reference layout body. What is this? Nav the that's nice. That should be a. I'll just connect everything. Yeah. Anyways. Wait, no, that's split second index. If you select the uh, trim split second index, trim split trim dot split second index. Nope. Oh, split every period and then add the second index. You got it. And then replace functions with then place. Since it is going to be string, I guess it's fine. I think somebody might have already done this, but somebody likely already did this. I just okay. But it's not defined though. Whatever. Let me just, I have to do something really quickly. We iterate chat, that's what we do. So, these sort of file structure I want to have. The sort of file structure I want to have is this. Hold on. So, routes, and then let's look at that. those route segments, I can have the actual routes themselves. For modularity, subsequently those route segments will have everything ranging from to, let's just do folder. Route segments would have those, and then the folder names would be this. Let's just do this. Folder would contain anything named, which should subsequently be the route segments, which would subsequently be the routes themselves. So a bit more context into that. While the root, folder root would contain a myriad of files. And all are variable n, so whatever. But the routes, individual routes themselves would just have also the same thing. TSX. So that's how I want to like format, if you catch my drift. Oh, my bad. I'm a rock star. I'm a rock star. Woke up to talking like me. Woke up to talking like me. up to look up to like the increase modularity. Okay, so backtracking. You have Russia finding route name, and then components which would subsequently house components would house the route name, and then the route name would house the page TSX and index XPS, and then yeah, and then the route, and then the route name would house. Oh, how about then the route name, the that was about it. Anyways, let's continue, shall we? Wait, did somebody actually respond? Did they actually respond? No. They put the tone. Okay. This was like 3 weeks ago. Master Chief was supposed to 5 weeks ago. Going to document taking this time, it was clear that the user side was a couple steps behind. Nice. Also, please don't confuse skill issue. Okay, okay, okay. Oh my god. Where is this from? Oh, genuine skill issue. If more details, some issues. I'm so Gen Z filled. Should I respond? I think we should also include an interfaces directory, but that's just me. I think components is sufficient, but whatever. No, anyways. Components is sufficient. Interface for what precisely? We don't necessarily need an interface. I think, practically speaking, a lot of the stuff can be moved to an interfaces directory. I believe, I think best practice shows that an interface directory would go within the app directory, and the interface directory would directly relate to the overall render of said. Maybe let's just change the components directory to an interface directory. That would be better practice, won't it? And then subsequently, if any of them do include the type and or interface keyword, they go within the types file at the folder path. Anyways, uh, okay, Paul. I should probably apologize. Apologies. Um, I don't think it was a Elysia issue per se. I believe it was an XGS issue. I don't think it was an XGS issue because I did this. Oh, this was pretty standard and standalone. was an XS issue. Yeah, definitely. I guess. Whatever. Like, for example. I think you forgot that there was that you needed ATT method to be exported for Next.js route, but I'm not gonna tell him. I'm gonna just change this to interface. That should be fine. Okay, okay, okay. That should be good. So, anyways, done.
So
Anyways,
Okay, so it's been a couple of months now since I've Okay, so it's been a couple of months now since I've completely abandoned TanstaQuery and Sustan, all in favor of Effect Atom. And the reason for that
Effect
is
Atom.
Effect Atom covers all
What?
use cases. It can easily replace all async and synchronous state management libraries out there. So when we're talking about TanstaQuery, we're talking about a synchronous state.
Does that
So
mean
you
that's really fuck
can
is this
query
entire code
data, you
base
can mutate
again?
data, you get easy
Yes,
loading, you
that's
get
exactly
easy
what it means.
fetching, you
Bizarre.
have
It's
some basic
pretty.
form of
I think
error handling,
Justin
some
is pretty
basic
clunky.
retries, but the moment you need to use it for synchronous state, well, it will simply
I'm
not
not even
cut it.
using
So you
Justin, man.
reach
That's
for
sad.
something
But
like
whatever.
Sustant, but now you have two different libraries. You have one for your async state and you have one for your synchronous state. But in my experience, Effect Atom does it in the most ergonomic way possible. But how can it work with the two? Well, for that, they have the concept of an atom of just t. So this is your synchronous state, and then you have an atom of a result of t. So they use this result here to represent async work. However, it's not just a result of t, but rather a result of t and e. So it can keep all errors typed. So you can pattern match against them when rendering your components. You can also apply retries, provide fallbacks, etc. All in a compile time safe way, which no other library offers. However, it's not the only thing it offers. It actually has a really powerful primitive for resource management, in that you can tie services to the life cycle of your components. So what I mean by this is, let's say we have A, which is the root of our whole application. Then we have B and C, and finally we have D and E as direct children for B. And let's say that B is rendered conditionally, maybe when the user is authenticated or when the user navigates to a specific part of your application. And let's say that B wants to run a background task. Maybe it wants to pull some data and all of its children unmount. You want to interrupt that background operation. Or let's say that you want to subscribe to a WebSocket channel. So you have a connect to channel, and on unmount you want to disconnect from the channel. And now you can derive an atom that represents the events that you get from that WebSocket channel. So now you can consume that in the any children this may have, and once all of them have stopped subscribing to this atom, you want to disconnect from the WebSocket channel. So as you can see, the options are endless. In the case of mobile, you want to open a file, then close it on unmount, etc. All tracked by the life cycle of the components. But then you might be wondering, what if we have yet another node? So we have another one under C, which also requires the WebSocket connection, so it can subscribe to this atom right here. Well, if B were to subscribe to it and E were to subscribe to it as well, then would we open the connection twice? Well, no. Effect Atom will ensure memoization across as many consumers as you may have. So if you have 1 to 100, only one will set up everything. And once all of the hundreds of listeners have disconnected, it is going to fire off the cleanup. Now what I'm going to show you is all powered by Effect, which is an incredibly powerful library accompanied by a huge ecosystem for working in all environments, so backend APIs, web, mobile applications, etc. So if you want to learn all about it, I've just released a course titled Practical Effect, where I teach you everything you need to know about the library. So make sure to check it out in the description. Okay, so now let's take a look at synchronous state. So for this, let's start with something basic, just a counter. We can increment, we can decrement, and if I click on this button, it is going to reset the count. So how can we do that with Effect Atom? Well, for that, first of all, make sure to have Effect as a dependency and at Effect Atom / Atom React. So as the name suggests, it has bindings for other frameworks, not just for React. Anyway, this is everything you need. And now, if I come here to the counter, instead of having this useState, we can create an atom. So we can say const count atom is equal to atom.make. We pass in the initial value. So this is going to give us back a writable atom with two type parameters. The first one is what it actually holds. So the state, in this case, a number. And the second one is what it expects objects to set the value. So in this case, it is going to be a number as well. So what you can write to this atom is a number logically. So with this, we can now come here and instead of saying use state, we can say use atom and we pass in the count atom. Now we can't create the atom here because every render will recreate the atom. So we need a stable reference. As we can see, we get back a tuple just like use state. We have count, which is the current state, and then a function that takes in value number, so the second type argument of writable, or a callback that gives us the previous value, just like use state. And that's it. Now we can come back here, and as we can see, we can increment this, we can decrement this, and reset the state. However, notice that we're providing an initial value, and that sum will hold a reference to that internally, which means that instead of saying for reset set count to 0, we can actually say use atom and then refresh, and we say count atom and we get the refresh function, which is just a function that returns void. And now we can say refresh, and by doing this, if I increment this and then click this, as we can see, we get back the initial value. So in this case, it is more like a reset back to initial state, but this will also work for async atoms. But now let's extract them into separate components. So let's have a decrement button, and here, instead of saying use atom, since we only need the set count, we can actually say use atom set, and that's it. We only get back the setter. So now we can replace this with our new decrement button component. So same thing for refresh, we can say reset button and then use atom refresh, and we need access to the count, so for that we can say use atom value, and this is just going to give us the current state. And finally, let's have the increment button. So pretty much the same thing as decrement button, and that's it. Now all of them consume the necessary pieces, and if I come back here, as we can see, it still works just fine. Now what if you have an atom that depends on another atom? So let's say that we have the base atom, which is just the count, but we want to have an atom that doubles the current state. So for that we can say double atom, and instead of saying that make and trying to synchronize the two, we actually get access to a function here which gives us the context, and this context is really a function that has different properties. So as we can see, we can mount an atom, we can set an atom, etc. But in our case, we can simply invoke it and we pass in the atom, and this is going to give us back the value, the current state of count atom. So now we can multiply this by 2, and now this atom will react to this atom, so it will basically subscribe to it. Any changes to count atom will be reflected for double atom, but notice that double atom isn't a writable atom because it is just deriving from count atom, so you cannot set to double atom. So if we were to say use atom set double atom, we're going to get a type error because again, this is not a writable atom. So now we can actually come here to count and simply say double atom, and if I save this and then come back here, as we can see, everything is now doubled and it works just fine. So again, it is reacting to that atom. Now let's say that we want to have a multiplier atom. So for this we can say atom.make, by default a multiplier of 1, and now we can come here and say const multiplier is equal to get multiplier atom, and then return get count atom times the multiplier. And now we can come here, say multiplier, and here we're going to say use atom, and we are going to render an input. So on change set multiplier, and now we can render this at the top. And with this, if I come here now, as we can see, with 1 we get increments of 1, and if we say 10, now it is going to react immediately, as we can see. So if I say multiply by 5, we get 35, by 100 we get 700, and so on. and we can reset it. So now it's 0. So again, by saying get, it is going to link it up for you. And now this atom will react to these two atoms. Now let's take a look at async atoms. So for that, let's create a to-dos. And here we're going to have a to-do atom. And let's say atom.make. Now you might be inclined to say async and then do an await fetch, but this is not going to work. As we can see, we get back an atom of a promise of void. So this is not going to work. So for that, atom uses effect under the hood. So when you actually pass in an effect to this make, it is going to treat it as if it were async, because effect allows you to have error handling, retries, timeouts, and well, of course, reaching it with promises. So we can say effect, and let's import effect from effect. And now we can use a generator. And here, what we can do is say to-dos is equal to yield, and then effect dot try promise. And then here we say fetch JSON placeholder. And now we can return yield and then effect dot promise. So let's cause a defect here, to-dos.json, and let's type this as unknown. So let's say that this is a promise of unknown. So as we can see, we get back an atom of a result. So again, result is for asynchronous atoms, but well, I guess you could also use it for synchronous atoms that might fail. So for the success channel, we get back unknown, and for the error channel, we get unknown exception. So everything is completely typed. So now let's create a to-dos component, and here what we can say is use atom value, and we're going to get back a result that succeeds with unknown and fails with unknown exception. So let's say that we want to show a loading spinner. How can we do that? Well, we can simply say, and let's rename this to to-dos result dot waiting. And this is a boolean. So if it's waiting, we can return loading. And with this, if I come here to app and then replace this with our to-dos component, and then come back here, if I refresh the page, as we can see, we get a flash of loading. Now what about the failure state? Well, we can check if to-dos result dot tag is equal to failure, then we get access to the cause, and this right here is an effect cause, a cause of an unknown exception. So for this, we can just return error, and instead of cause.message, we can say cause.pretty, and this will return a string, so converts a cause into a human readable string. And now we can get rid of this, and if I come here and let's turn off my internet, so let's go with offline and refresh. Of course, it is not going to work, so what we're going to do is say const refresh, use atom refresh, and we actually need to render the button at all times. So let's go with export const to-dos, and this right here is the inner component. So now we can have the refresh like this, and if I save this and turn on back my network and then turn this offline again, if I click on refresh, as we can see, we got the error here. But obviously this isn't very user friendly. You wouldn't show this whole error to the user. So what you can do here is actually say const failure option and then cause dot failure option and then to-dos result dot cause, and this is going to give you back an option of unknown exception, none if there's no expected error, so it was a defect, some if there was an unknown exception. So now we can come here, say return option from effect dot match, and now we can say on some we can get the narrowed down error, as we can see here. So unknown exception, really cool. And here on none we can simply say unknown error, and if I save this and come back here, click on refresh, as we can see, we now get error. An unknown error occurred in effect try promise. Now what if you want to show the success value? Well, for that you would need to check for the success branch. So if todo's result.tag is success, then you get access to the value. But we can't do that here because it can still be of initial state. So for this, what we can do is instead of saying todo's result.waiting, we can say todo's result.tag is equal to initial, and that way, after checking for these two cases, we get access to the value. So as we can see, it is basically the unwrapped value of the result. So now we can come here and stringify it. And if I save this, as we can see, we get all of the to-dos here. But how exactly does initial work? Well, if I refresh this, as we can see, it doesn't show a loading spinner. So is this doing anything whatsoever? Well, let's confirm that by logging to this result, and as we can see, it is success. And if I refresh, we get new logs. So we get waiting true and then waiting false. So in our case, if we check for just the initial tag, we're basically mimicking is loading from Tansta query. If you want is fetching, you would check against the waiting property, meaning that this is not going to show the loading spinner for any subsequent refreshes. So this is one way to achieve that. However, it doesn't hold true for all cases. And what I mean by that is in atom.make, we can pass in a second argument, which is an object, and here we can say initial value is an empty array. And by doing this, if I refresh, by default, it is going to have a tag of success, and as we can see, wait by default can hold true for all cases. And what I mean by that is in atom.make, we can pass in a second argument, which is an object, and here we can say initial value is an empty array. And by doing this, if I refresh, by default, it is going to have a tag of success, and as we can see, waiting true. So it fires off, but as the initial state, we're going to get an empty array. So in this case, we never show a loading spinner. However, this is a little bit imperative. We need to manually handle the different cases, say failure option for failure, then match this option, and so on and so forth, which can be a bit verbose. Fortunately, the result module comes with a builder, so we can get rid of this and simply say result and then builder, and we pass in todo's result. And with this, we can now say on error tag, and we can say for unknown exception, we can say unknown error, then we have the on defect, so an unexpected error. So we can say unexpected error. Then we have the case for uninitial, so we can say loading, and we have the case for unsuccess, so we can just stringify them. However, we need to convert this into a React node, but since we're not handling all possible cases, we can simply say or null. Or you can say render, but this is going to throw an error if I'm not mistaken. So if we come here to render, as we can see, if this is a failure, then it is going to throw the prioritized defect. So with this, we can now save this, come back here, and as we can see, we still get the very same behavior, but in a really declarative way. And if we were to have more errors, so let's say we have the to-do schema, so to-do or class to-do extends schema, and here we must pass in self, the identifier, and then the fields. We can say ID, title completed, and then we can come here, pipe through these, and then say fact.flatmap schema, the code unknown, and then say to do. And with this, we can now come here and say on error tag, and then parse error. We can get access to the error here and simply say error.message. And now if we run this, as we can see, we get the error here. Okay, so now let's take a look at finalizers. So for this, let's have a conditional component, more like tabs. And here export const tabs, and then we can say active tab, and this is going to be either 0 or 1, and this is not use atom but use state. And now we can return a div. Let's have two buttons, and then let's render the different components. So let's go with tab 1 and tab 2. And now let's say that we want to run a finalizer on an atom once there are no active listeners. So how can we achieve that? Well, let's create a finalizer atom, and this will be a make with an effect.gen. And let's say that we're fetching some data and whatnot, but we can say yield effect.add finalizer. And then we can say console.log finalizer. And let's say that only tab 1 consumes it. So instead of using the value, this doesn't produce anything, we can say use atom and then mount. And this is simply going to mount it, so it is going to subscribe to it, but we're not going to get any data back or whatever. But tab 2 doesn't consume it. Or let's actually do it the other way around. So tab 2, and let's run an effect.log saying finalizer atom, and let's use console for this instead. Now if I replace this in app and say tabs, if I now come here, as we can see, we do not have any logs. Once I click on tab 2, we get a finalizer atom, but once I go back to tab 1, as we can see, the finalizer executed. Now it doesn't execute immediately. It actually has a bucketing system internally to determine which atoms should expire at what time, but I have a dedicated video on that, so make sure to check it out in the description. So now let's take a look at how we can have polling. So for that, I'll create a new component called todos polling. And here, I'm simply going to copy everything from todos. So for this, we need to fork a fiber that will periodically fetch the data, and it will update the atom. But we need to tie the fiber to the life cycle of the atom. So if everyone stops listening to the atom, it should interrupt the fiber. So let's create a get todos computation, which is just a try promise, and here we're going to pipe through this, say effect.flatmap, and then we can say response.json, and finally schema.decodeunknown. But let's actually add a log. So let's say effect.ensuring, and then console.log, and then get todos finished. And now we can come here and simply say return yield get todos. And if I now render the todos polling, which I did not rename here, we can now see that we get the log here, get todos finished. But we're getting a parse error, so let me actually check what we're getting back. So we're getting an ID, title, and completed, but it's an array, not just one to do, of course. So schema.array, and as we can see, it now works. So now we can come here and say yield effect.forkScoped, and then get todos. So Atom will actually create a scope under the hood, and instead of tying the scope to the lifecycle of just this effect, it will tie it to the lifecycle of the atom itself. So when we're saying yield effect.forkScoped, again, we're tying that to the lifecycle of the atom, not to this effect here. So now we can come here, pipe through this, and then say effect.onExit. We get the exit here, and then we can get access to the context here, and then say get, and this is a function, effect.function, and then say set self, and then we can say result dot from exit, and we pass in the exit here, and this needs to be an effect, so we can say effect dot synchronous, but we need to repeat this, of course. So we need to say effect dot repeat, and then we can say schedule dot spaced, so every 2.5 seconds. And if I save this and then come back here, as we can see, we get todos finished 12, 13, 14, and if I come here and log the todos result, as we can see, we get todos finished, then we get tag success, then finished, and so on and so forth. So this is how you can achieve polling. But of course, if you wanted to update another atom and not self, then you would say get.set, and then you pass in the atom and then the corresponding value. But again, this is imperative. We want a declarative solution. So for that, atom.make takes in an effect or a stream. So let's learn how that works. So let's go with todo's polling, but stream instead. Let's copy this whole thing and then let's say todo's polling stream. And now, instead of having these fork scopes and then this result from exit, we can replace this whole thing with a stream. So we can say stream and then from effect, so it will emit the success value of this effect or terminate the stream with the failure value of this effect. And we can say get todos and we get back a stream here. So we have an atom of a result of an array of todos or unknown exception or parse error. But if we just do this and then come here, as we can see, we get waiting true and then waiting false. But if we come here and say stream.repeat and then schedule 2.5 and then refresh, as we can see, we got get todos finished, but waiting is still true. So why is that? Well, that's because with streams, as long as the stream hasn't terminated, so as long as it is still producing something, then waiting will still be true. Once the stream terminates, it is going to be set to false, and it terminates on errors, on defects, etc. So we can actually say repeat n, but stream doesn't have that, so we can say schedule dot spaced intersect and then schedule dot and then recurse for 5 times. And if I save this, refresh, and wait a bit, I shouldn't have went with 5, but as we can see, it finished. So now waiting is false. The stream has terminated. So now you can start to imagine how powerful this is. All you need to do is have a stream here and produce whatever you want. So you could set up your server sent events here, and every time you get a new event, all of the consumers will be updated. But I'm going to show that later on. Okay, so now let's take a look at mutations. So for that, let's create a todo's CRUD, and here we're going to have different atoms. So we're going to have the get todo's atom. So get atom is equal to atom.make, and here let's simply say effect and then promise and then fetch this, and then we can get the JSON, so response.json, and let's use schema for this. So now we can come here, say todos is equal to use atom value, and again let's use the result builder. So result.builder for todos result, and then we can say on initial loading, on error tag, well, we do not have any expected errors except for parse error, so let's actually say effect or die, so everything is a defect. And then we can render the form, so we can have form, and let's create our atom for the create mutation. So here we need to say atom.function, and now if you mount this atom, it is not going to fire it off, so this will now take in an argument. So here we can say to do a string, and this should be an effect dot function, and as we can see, we get back an atom result function where the first parameter is the input type. So as we can see, it is of type string. If I were to say this is an object with the todo string, as we can see, it is now an object of todo string. Then we have the success channel, and then we have the error channel. So let's actually rename these to input. And as for the second argument, we get access to the get, which is an atom.function context. And same thing, we can invoke it and pass in an atom. Now in this case, let's simulate a request, so we can say sleep for 1.5 seconds, and here we can say get dot and then refresh, and then we can say get atom, and that's it. So now we can come here and say const and then result comma create to do, and we can say use atom and then create atom, and this is going to give us the result of the mutation, and this is going to give us the setter, which is a function that takes in our input, or an atom dot reset symbol for resetting the mutation to its initial state, or an atom dot interrupt to interrupt the ongoing mutation, or just a result in itself, matching well the types of the mutation atom. So now we can come here and then say form, and then we have the input name to do, and we can show a loader here. So we can say result dot waiting, if so creating, else create. And now we can render it here, and that's pretty much it. Now I can come here and render the to-dos CRUD, and let's try it out. Let's see if it works. Now before doing that, let's actually render them nicely. So I created a to-do list component. So now if we come here, as we can see, we get all of the to-dos here, but we have one small problem. We can't create one because we're just refreshing the remote ones, which are predefined. This is just the static data. So let's do something ugly for now, and that is, let's keep a constant here, which is to-dos, and this is an array of to-dos. And here we actually say promise.resolve to-dos. And well, there's no need to decode anything nor do an or die. So we can actually say effect dot sleep for 1 second, and then we can say effect dot as to-dos. And now all we need to do is push to to-dos. So to-dos dot push, and then we refresh the atom. And that's it. Now, if I come here, hit refresh, we get the loading spinner, or well, the loading paragraph. And if I type test and click on create, we get creating. And it did not work because I forgot to save the file. So again, click on create, and we get the to-do here. But obviously this is far from ideal. So let's take a look at atom.writable. So for that, let's say that getAtom is really just an empty array. So this in reality would be the remote atom, or the remote getAtom. But here we need another atom, an atom that subscribes to this remote getAtom, and an atom that we can write to, so that we can mutate its cache. So for that, we can say const getAtom, and this is atom.writable, and we need to pass in 2 arguments. We need to pass in the read function, which is going to give us the atom context, and here this returns r, which corresponds to the read value of the atom. And then we have the second argument, which is a write function, which gives us the atom context, and here we specify what we expect as input for this writable atom, in this case an array of to-dos. So what we get back is a writable atom that gives us a result of to-dos. So when we say use atom value, this is what we're going to get back. And when we're setting to this atom, so via use atom set or via get.set, it is going to expect in an array of to-dos. So now with this, we can come here and say const to-dos is equal to getAtom, and we get back a result. So we would need to check if to-dos dot tag is success, then we can set it. However, we can simply do a yield and then get dot result, and since result is treated like an effect, we can yield it, and it is going to propagate any errors of this result to this effect. In this case, any errors that remote getAtom fails with. And so with this, we can now say get and then set, and we can say getAtom, not remote getAtom, because this is not a writable atom, and all we need to do is spread over to-dos and append the new one. Or you can use array from effect and then say append to to-dos this object. and we can now get rid of this refresh. Otherwise, it is going to read again from remote atom and it is going to overwrite our cache mutations. And with this, if we come here and create a new to-do, as we can see, it works. Now let's add a way to toggle the completed status of a to-do. So for this, I'm going to extract the list item into its own component. So to-do item, this is a function component, takes in a to-do, and here we're simply going to add braces to this arrow function, and now we can create the atom. So we can say const toggle atom, and this is a function. This takes in the to-do, and we're simply going to say fact.sleep for a second, and then we can say array.replace, which takes in the array and then the index, and we have the new value here. So now we can come here to do item and then say toggle result, comma toggle to do with use atom. And now we can come here and add an unchange, toggling the to do, and we can disable this as well if toggle result is waiting. And now we can come back here and create a to do, and if I check it, as we can see, it is disabled if it's waiting, otherwise we can toggle it successfully. However, there's one problem with this approach, and that is if we have multiple to-dos. So let me make this clearer. If I add a loading state here, so waiting else done, and if I create two to-dos, and then I toggle one, we get waiting for the two. So why is that? Well, that's because we're sharing the same atom for all to-do items. So all of them ultimately point to the same reference. So what can we do in that case? Well, for that, I would recommend using atom.family. So here for toggle atom, we can say atom.family, and the key will be the ID of the to-do, just like this. And let's not even use this argument. This will just be used as the key internally. So now this is a function that takes in the to-do ID and will give us back the corresponding atom. So it is going to internally store everything in a map. So if I come here, as we can see, it is going to create a mutable hash map, and then it is going to check, is there an atom? If so, then return the entry. Otherwise, invoke the function that we defined, and so we get the new atom here, and then it is going to say hashmap.set new atom, and returns the new atom, and that's it. So nothing fancy at all. However, if you take a look at these conditions, it actually checks if there's a weak ref defined or if there is a finalization registry defined, which is just for garbage collection. So when no one references a specific atom, it will get garbage collected and removed from the cache automatically. So now what we need to do is invoke toggle atom and pass in the ID, and that's it. So now if I come back here and create some test to-dos, if I toggle one, as we can see, it is no longer sharing this state. And in fact, since atom family uses a mutable hash map under the hood, you can leverage equality and hash from effect. However, I'm not a fan of this, of letting consumers do whatever they want with the data. I like to expose an interface, a contract. So for that, since this dictates the input type, you can actually leverage effects tagged enums. So you can say type and then cache update, and this is equal to data.taggedEnum, and here we can say create, and this just takes in the to-do, which is a string, and then toggle, which takes in the ID of the to-do, and now we can say cache update is equal to data.taggedEnum, and here we must pass in the type like this, so cache update. And now for the value, we simply say this takes in a cache update, and we can say const result is equal to, and then context dot, and then we can say get, and we get self like this, and we can check if result.tag is different from success, then do not do anything whatsoever. Otherwise, we can now say cache update dot match, and we take in the update here, and now we get this really nice ergonomic API where we take in the arguments here, and now we can say array.append to result, and then we can create our to-do like this, and this is actually result.value, and then for toggle, same thing, and this would be result.value, and here we get the new result. So now we can say context.setSelf and then result.success. And now for the consumers, all we need to do is say cache update.create, and we do not need to yield the result anymore. And then for set, same thing. We simply say cache update.toggle, and now we can rename the key of the family. And as for the actual function, well, we can omit all of this. And instead of saying this is void and then get is the atom.function context, we can actually access the registry by saying yield atom and then not registry but import registry from artifact atom and then dot atom registry, and now we can say registry dot set. So the registry is the one that keeps the references to all of the atoms, will invalidate the atoms, etc. And atom.function and atom.make will provide this registry for you. So that's why we do not get any type errors here. And that's it. Now we can omit this. And if we come back here, as we can see, it still works. We can toggle everything and we can create them. However, it encountered two children with the same key. So for the ID, let's just use crypta and then random UID. And we're good to go. So now if I create some to-dos, now everything works perfectly. Awesome. Okay, so now let's take a look at interruption and runtimes. So for this, I have this AI search assistant that I developed for my previous video. So make sure to check it out to understand how everything works from scratch. But in essence, we can search for something here and it is going to search the web. It is going to evaluate the candidates and finally it is going to summarize everything. And everything is streamed in via server sent events. So as we can see, we get the chunks here, and if I click cancel, it is going to interrupt everything, and that results in a 499. So a client closed the connection. So to achieve that, I used the streams. So I created an atom function that takes in the query, and it is going to access the RPC client so that we can then say client.search and pass in the query. But this is a service, so we can't just say atom.function. That's not going to work. We need to create a runtime that provides the layer. So in that case, we can use atom.runtime and we pass in our layers. So we can say merge all, etc. In my case, it's just RPC client.default, and this one has other dependencies as well. And what you get back is an atom runtime that provides the RPC client. So now with this, whenever you say runtime.function, you can yield the RPC client. And to create an atom that's not a function but perhaps a query, you would say runtime.atom instead of atom.make. And same thing, you can now come here, say gen, and yield the RPC client. And what you're going to get back is an atom of a result of void and never. But how does the life cycle of the services work like? Well, they are tied to the life cycle of its consumers. Once there are no listeners to any atoms referencing this runtime, then it is going to dispose of your services. Okay, and finally, let's now take a look at infinite scrolling. So here we get all of the posts. I click load more, it is going to fetch the next 10 and so on and so forth. So how can we achieve that? Well, for that I created a runtime. So atom.runtime with fetch HTTP client.layer. Then I have the post schema, and here we have runtime.pool. So pool, if we take a look at the types, expects you to provide a stream, and it is going to give us back a writable of pool result of the produced elements by the stream. And what is a pool result? Well, it is just a result where for the success channel you have done, which is a boolean, then you have the items, which are accumulated, and then for the error channel, well, you have the errors from the stream, and it adds no such elements exception, and that represents the case where there were no items to begin with. And that's it. So with this we can say stream.paginate effect. We start at page 1, then we have our effect here, we yield the HTTP client tag, and then we do a get request, and then we check if there are no posts, then we can return option.none, which is what paginate effect expects. Otherwise, we can say option.sum with page plus 1, which is what we're going to receive here for the next one. And that's it. And then we flat map the posts with a stream dot from iterable. And finally, for the component, we say use atom, and here we get the result, and we get access to this load next page. And that's it, a result.builder. And for the button, we just simply say load next page. So as we can see, Effect Atom makes a lot of things super straightforward, especially because it is built with Effect, and you get all of the goodies of Effect. You have a structured concurrency, you have error handling, retries, and so on. Anyway, this wraps up the video. If you want to see more content like this, make sure to subscribe. I'll see you in the next one.
Okay, I'll take like 10-minute break. I'll be back though, and hopefully the music still works.
Okay, so it's been a couple of months now.
without without everyone in this video I'm on
Yeah, yeah, I could have just used that, but it just
everyone in
I didn't feel like using a dependency because it's a bit clunky.
everyone in this video I'm going to talk about PDF files and how you can display PDF files to your users, how you can render them on the
Anyway, I'll
page,
take
how
like
you can
a break.
load in new PDF files, and how you can let your users interact with them. So I have this PDF receipt vault app. So the idea here is that users can upload a PDF file. This can be of their receipt. So you paid for something, you want to keep track of it, and then they can keep track of that in this app. So maybe we can add some categories, for example, or we can see where they're spending all the money. Mostly useful for bookkeeping or accounting purposes if you have a small business, let's say. I'm viewing the PDF file in this component here, this PDF viewer component. This is a super powerful component. I can do all sorts of things with it, which I will show you in the video. But this is coming from Syncfusion. They are also today's sponsor. I've used them in the past. They have some extremely powerful components. This is just one of them. They have a complete suite. But in this video, I'll show you how to get started with their React PDF viewer component, how to set it up, how to customize it, and some of the benefits that you get with it. So some of the things that I can already do right here is, of course, I can zoom in and out. I can fit it to the width of the viewport there or to the page. I can zoom in like this. I can also search for text, by the way. So if I want to see all my receipts, so if I want to see the type of payment, I can find it right here. It will actually annotate this with a color for me so I can easily view the match. If I have multiple pages, I can easily switch that. I'll show you that as well. I can add annotations myself like this as well. So if you do want to underline something, maybe the date here, I can add an underline. We can add an edit form field. So maybe you do want to add some additional information here, maybe a signature. Maybe you want to have a signature on the receipt. We can do all of that here as well. I'll show you all of that in the video, but let's actually just get started and clear this out. So now it's gone again. So actually you can see that I'm not only able to interact within the component itself, it's also often the case that outside this component in our app, we want to be able to programmatically change things in this PDF viewer component. And so I just cleared it out. So you can see I'm able to interact directly within the component itself, but the app is also able to programmatically change things here in the PDF viewer component, right? Which is often what we want to do if we're building an app. There will be other functionalities in the app, and the PDF viewer component needs to react to that, right? So you can see this is all being programmatically done here. I can switch between the PDF files. I can load new ones. I was able to find this cache. In this case, it didn't find anything, and it shows me this dialog. I can even change the locale. So in that case, you can see when I hover this, the tooltips, they actually display a different language, actually Spanish in this case. I can download that if I want and print it as well. So very powerful, but let's actually show how to get started with this, how to set it up, and how the options work. All right, so I just opened up my code editor, starting from a clean slate here. I don't have anything right now. Let's actually start by spinning up a new React app. I'm going to use Vite here. I will just go through the setup here. So let's actually start by just creating a new Vite application here in this folder. We will pick React here, just go with the default options here. All right, so everything has been installed. Let's open it up in the browser here. So right now we just have the boilerplate. So let's actually just go here and clear out this boilerplate here. I will just remove everything here that we don't need. So now it's just an empty page. Let me actually, now there's a lot of default styling here as well, which I'm going to replace with my own styling here. So basically just making sure that the entire web app fits on one viewport essentially, so we don't have to scroll. So we actually just have a blank page right now. So let's actually get started with the actual PDF viewer component. How can we get that on the page? So Syncfusion does have a getting started guide here for the PDF viewer component, and we are using React here, but works with other frameworks as well. Now, there are a couple of different options that you have to know about to completely understand this, which is that you can use this component in what they call standalone mode, but also in server-backed mode. So with standalone, which is what I was using here, what we will use here, basically we are downloading that, you could say, engine to actually render the PDF, open it up and render it. We are going to install that locally onto our computers, but if you do want to have more server-side capability, because maybe you do want to keep some things on the server side, perhaps for performance reasons or security reasons, that is possible as well, but we will go with the standalone PDF viewer. So I will install their package. All right, just npm install right here. All right, so now we have it installed in our node modules folder. But in React Vite, if you're using a static asset, we often want to bring it into either assets or public. So in this case, they actually give us a script so we can easily move that into the public folder. So let's actually run that. But if I run this, you can see I now have this folder here that has a WebAssembly file and this JavaScript file. Okay, so this will allow us to open the PDF file, render it. Okay, so then they also have some styling that we can bring in. Now they show an add import here, so we could add it to index.css. However, I was also able to make it work by just importing it here in the tsx file itself. And then here they give you a snippet just to have a boilerplate. So if we copy that and if I import the components now, you can see it's a root component here, the PDF viewer component itself. But then there is also this inject. So basically the PDF viewer will have certain features like a toolbar. We can zoom in and out as we just saw. That's magnification, navigate between pages and so on. We need to bring those in individually so we can keep the base small. So we're not unnecessarily adding things that we're not going to use. And then if you do decide that you want to have a print feature, basically, you need to individually inject that here as a service. Okay, so this allows it to stay performant, for example. So we can just import these. All right, so now I have imported everything. Let's go to the page and see what we have so far. All right, so here we now see something here. So they have a default PDF file that they show. And then here we see a message about the license. So Syncfusion offers this premium component suite, and they put a lot of time and energy into this. It's very powerful, it's very comprehensive. In some cases you do need a paid license for that. However, they do have some free options as well. If you just quickly want to try it out and get started, you can try a free trial, And if you log into your account, then you can get an API key. So check out the link in the description to do that. And once you have the API key, I can go to the root of your component. So let's actually go to main.tsx here, and we just have to register that license once. So you can import the register license function from their EJ2 base npm module, and then you can just call it with the API key in here. All right, so if we do all of that, we can see that we now have a PDF file being loaded here. We don't see any controls yet. We'll fix that in a second, but at least displaying it, rendering it on the page properly with all its content, including page numbers. All of that is working now. This is a massive file, so it's good news that we can see everything and it's being rendered properly. Of course, we want to add the controls now as well, but just to show you how you can load PDF files. So there is this document path here. That's going to be the actual PDF file that you want to display. And then here they have a resource URL. So this is for the actual engine. This is the actual library that you need to make it work. So this can also change depending on whether you're doing it locally or if you're doing it with a web service API. We can also add styling here, and here it's setting a fixed height. But if you're incorporating the PDF viewer into an existing app, you probably have some kind of container element around it. So probably it should just take up 100% of that. So I will actually change this into just taking up 100% of whatever we're going to add here as the container for this. And I will also change the background color. So now you can see it's actually taking up 100% of the page, right? But if we have an existing, but typically we want to incorporate this as part of a larger application. So let's actually see how we can do that, and then also how we can add the controls and other options. Because we have injected these services now, but I don't see any magnification icon, for example, right? So we need to actually do something more to make these services work. So some of these services like magnification, when you have like the magnifying icon, those are going to be part of the toolbar. So if we don't show any toolbar, you may not even see that either. And that's also true for some of those other ones. So what we can do is actually set the toolbar settings. We can then specify the tools that we actually want to show in that toolbar, right? So we actually have some controls to manipulate the PDF. We can also specify if we want to show tooltip, and TypeScript is working perfectly fine here. So if you want to see the options, you can always use type inference here to see the options that you have, right? Same goes for the props here. So you can see that we have all of these props. It's super powerful. So for pretty much anything that you have in your mind, you can probably get it exactly or very close to what you want by using these options that you have. You just have to use, if you're using TypeScript, it's even easier because you get this type inference. But if you're using plain JavaScript, of course, they have an API reference as well. But if we now go back here, I changed some things so we can actually view a more powerful PDF file as well. So now we still have the PDF viewer component, but it's sitting inside a container, and it's just taking up 100% of that container, which is probably what you want if you're incorporating. And then around it, we now have our app UI, right? So we have all these controls, right? So here we have our PDF receipt fault app UI. And then in here, this box here, I'm putting that component. And now in here, we see the toolbar as well, right? So now we do see zoom in, zoom out. I can pan, right? So I can actually move it around. I can find text natively inside this component as well. I can add annotations, so I can say, hey, this text here, this needs to be different, right? Or maybe somebody else needs to take a look at it and I want to highlight it, right? So there's all these tools here to annotate the PDF, including underline, track through, squiggly text, but also shapes. So if you do want to add your arrows, you can do that here as well. We can add and edit form fields as well, download it, and way more. Now all of this is configured here, so you can see all of these options that I added: a print option, download option. These are the options here, but remember, you do need to inject them as services or they're not going to show up. Now I'm loading a different PDF file here because it's a little bit more powerful. So they actually have some really nice PDF files on the website, and this one has to do with a lease agreement. So this is a bit more of a complex PDF file. If I just refresh here, you can see this one has form fields, for example. So here I can then sign, and it opens up this modal here. And I can also fill out my other information here in these form field, right? So all of that is possible here. But now let's say I want to programmatically change the PDF file that is being shown here. So if I click on the second receipt here, now I'm showing a receipt here, right? So I can actually switch between the PDF file being shown programmatically here as well. Okay, and we can do that by getting a reference to the viewer, and then we can call the load method on there. We just have to pass the source of the PDF that you want to display. Now I can also load receipts dynamically here. So if you actually have some kind of upload feature, I can have, for example, that big PDF file again. Let's actually load that. So now you can see I'm loading a huge PDF file and it's being added here to the list, but it can automatically be shown then as well. But you can see this is a big PDF file, right? It's displayed very fast and with very good performance here, right? So you can see I can scroll up and down pretty fast, and it's able to render it very quickly when I'm actually still again, okay? Now I can then also switch between pages, right? So there is also some page features here, last page, previous page, and it's really fast, right? So this is all very fast. There are also page thumbnails. So if you have a large PDF file and you want your users to be able easily search through those files, all of that is possible here as well. If you're a little bit overwhelmed by all those options, just check out their documentation here. It's all described. And so for example, if you do want to customize the toolbar, it's all described here. The type of tools that you can hide or display, it's all described here. If you want to try out the PDF component but you don't want to set up a complete app, check out their samples page here. They actually have some really nice samples, and you can probably find a sample that's really close to your own use case. So here, if I zoom out a little bit, they have a default PDF component here, standalone, but again, you can also use the remote option. If you have a read-only document where I should not be able to edit it, for example, right? So now I'm clicking in the form fields, but I cannot edit. You can do that as well. If you have like a list of PDF files and you want to display perhaps one in a modal, for example, you can see it opens up right here as well. If you want to give your users the ability to easily redact some information, for example, I want to black out this part here, you can see I'm drawing this black box here, and then I can click on redact and it will sort of burn that into the PDF. So now you can see I cannot read this anymore. Actually works with text as well. So I can say this PDF files, if I just draw on top of that and click on redact, it will actually remove that and display redacted, right? So let me actually, you can see now I have redacted. All right, so you can also add forms here. So you can add form fields so people can actually fill out information, not just input fields, also checkboxes and radio buttons like this, a full form. And then I can also sign here, right? So we already saw that, but I can then also download this file. And if I then open it up, you can see I get the PDF file, including the information that I filled out. All right, so with annotations, you can highlight something, for example, and you can download it then, and then when it's opened again, it's going to display the annotation again. And it includes shapes as well, even badges or stamps or sticky notes and ink. Now you can do that programmatically as well. So here in my app, if I want to have a rectangle in the PDF file, but it's being controlled somewhere else in my app, like this panel here, which is outside this React component, I can still add annotation here, and you can see I've specified the coordinates for where it should be placed. You can see it was placed in that position with those dimensions, etc. And there are of course also signature options that we saw. So you can get really, really advanced with this. But I think you get the point, which is that this is a really powerful PDF viewer component for React, but not just for React. So if you're using Angular in some other project or you have some other tech stack, so check out Syncfusion here for the React PDF viewer. Actually, they have a ton of other components as well. So check out my other videos with Syncfusion. In any case, thanks for watching, and I hope this helps you out. Have a nice day. Bye.
what is this? UTF-8 explain. It's global. It's language that's not. It's the global. Okay, hold on. UTF-8 means that it's globally recognized as a language protocol. And not specifically unique to any set language. For text or whatever, there's like a whole Microsoft article on it. A lot of interesting things in the news. Type
Really
okay.
learn or
Everyone, in this video I'm going to talk about PDF files and how you can display PDF files to your users, how you can render them on the page, how you can load in new PDF files, and how you can
I had to check those. Just read these. Free to share, copy, and retrieve the material in any medium like format, remix, transformation. This cannot revoke these freedoms as long as you follow the license terms. Once you have appropriate credit, you may not use material for commercial purposes. The remix, transform, and building must distribute contributions of the same license as original. Cool. Apache 2.0. Okay. Attribution 4.0 is national. Share. Dap remix. And then in my free to appropriate credit, click to look to license and indicate if changes were made. You may do so and it doesn't matter. Okay. Cool. That seems reasonable. So it did it wrong. Yeah, I did it wrong. The app directory should look a lot better in like 20 minutes or so. I did not test out the APIs because I know that the APIs routes are probably not gonna work. They should work. I followed everything to a T. The only problem might be is the functionality in of itself and mismatched types. Since the types aren't explicitly generic or like basic, they're complex types, complex generics. Because with utilizing this library, it's definitely complex. Okay, you're gonna take another break, cause yeah. And then the only thing that's left is just like new routes and fixing the API integrations and yeah, just looking at like things to make the application faster. We didn't like degree speed or performance test, so I don't really know. that's about it. And then there are the workflows that we have to take into account. Uh, oh, I might do better. Anyways. Except for the. gonna keep doing this, isn't it? Not very efficient. No, upload imports. It's okay.
One of the
Learn fast, they said. It would be beneficial, they said.
every so
now since have
I'm gone. Alright, so I'm gonna tell you a small
Hello, everybody, and welcome.
Alright, so
You just made the best.
To me again. I recorded multiple videos in the same night. I changed my hair a little bit so you can keep suspending.
So AI coding. So AI coding. Welcome to Amit Thinks.
Okay, so I just. Okay, so I just. So I just stumbled.
I am.
Hey, I'm Harry. I'm an engineer at Warp, and I've been part of the work on making AI use.
So I need to write this or just import it from the bin directory. Some just in case you actually import these packages. Why would we send? Let's see, because they are large. That's why. I gotta make a, and then what's it being? Oh, so anything. From like the megabytes or whatever. How much am I using? Okay. Cannot be parsed as 0. those should be this should be entirely dependent on this output. I'm just waiting on the output. It's not, no, it's not defined. That's cute. Did I just do something? No, anyways. Let's reload the window and see if it's... Not necessarily, but just like, they're all at root, so why not? And it's still there, wow. Okay. Should we change this? Could have just left the same thing. Instead of that, I'm just gonna do... See this? I'm just gonna do... Pi... Name... is Shingify, so building on top of this, we just gotta building on top of this, you just gotta like do this and like what is it called? And we do the same thing for everything else as well. High, low, mid. Rather than just doing this. We import it as JSON, just like high. High JSON and we import it as JSON. So it's meant to be imported as signed out. Hold on. So import as import yes with assert type and then it goes the same as everything else. And then we just do that but with everything else. Insert high, medium, low. And that's pretty much it. High, medium, low, and then move this high. That's basically it. What's it working on? Anyways, let's just solve this really quickly for just importing it. that, and that should work, as expected. Where is it? Oh. Okay. PWD. don't know if this list, I don't remember. 256 and import these packages. Can I elaborate on it? Like, can I make it dynamic? Or whatever. Let me just do something really quickly. Like, something really, really advanced. Not really advanced, it's just like... Six, seven... Okay, so this thing, or whatever, okay, there it is. This one. This, let's see, hit install, doc install, PyPy, and then put install as pip, what, let's see it. Let's just PyPy packages, PyPy packages, install. There it is. Yeah. Anyways. Yeah. Anyways, when was the last time I was updated? 2 years ago. Documentation is 2 years ago. Scripts, 3 years ago. Notebooks, 3 years ago. Red Dog. Let's see. Two last year and then 3 years ago. Recorders, scanners, 5 months ago. It's pretty fresh. I'm assuming I need PyPy or pip. There's no other option. This might be the only one. It's just more reliable. Whatever that was, or this. Whatever it's doing here, or this. Okay. Oh, it wasn't even this one. submit this really quickly. Yeah, this is definitely it. Anyways, this is, I don't know. Shouldn't be anything bad. Another Elysia W. Anyways, pretty standard. Hey. www. World Wide Web. doing? Oh yeah. GTM, GTM. I guess that's fine. Config, next public, next public. If it includes public, Google Maps API. Breadcrumb. Some. Data set some. Red rum. What am I? Where's this conflict coming from? Const equals a way to import const. Equals a way to import. And then the mod default mod config the Google Maps API key. Red rum. Anyways, it's hot in here. So, what I was going to do was update update these actually. Yeah, perfect. Just got the types. default font would be. This was like general font data, and then error layout, and then next config. Yeah, fonts not bold. Bold. Yeah. Then default type changing property template string. Metadata template string. You just use string constructor, string type constructor. It doesn't even make sense. The image response then just returns whatever. I guess it's fine. I gotta see this out, cause yikes. Okay. I just fixed like the fonts, and that was about that. Okay. That was about it. I don't think I need any more scripts. There's even more optimizations that I need. There is like the other thing, if I can just like bring that up. There's this integration with like whatever this is. Audit and yeah. config should. Where am I getting deriving config from? Config should be implied. They return default config. Country config is explicitly just this. Config is next config with combined config with country config. With country config is possessive of any. So this also implicitly a type of any. So should I just do ts ignore? If million returns a type any, so they should also be of type any. Explicitly a type of any, so just do any. I can't like transmodify it or whatever. So I'm just gonna do explicit any. That should be good. Anyways, so let's go to this client. Oh no, I don't need those. Why do I need this? This API service, the same thing. Eden treaty rather Eden fetch. I don't need those. So let me just do the same thing as before. And oh, forgot. Sorry. And just get out of that and then just do this. I'm not calling. I don't have fun now, and it should not be this API. API v1. API. Is it? I think it should. API. For content would be really good. Yeah. So now. This isn't gonna slide. So now. Am I using like any expensive stuff? Crypto, Lodash. No, anyways. Crypto is expensive. Say no. Say no. I'm way too important. There's not like anything else, actually. There's SAIO. SAIO, like some other tips. SEO tips. Let me just pull those up. H1 title. Let's see. Hi, my brain rot. Sisu makes me. Actually, I have. Anyways, let's take a little break. go.
Totally.
testing out till 3, hopefully. Okay, not as much, but still sizable amount. It's mainly not too much, not too much, not too much, not too much, too much, not too much. Start made, start made, start made, schema types, schema. Start made. Oh my god. Oh, it's gonna be a headache. This is gonna be a headache. Yeah, this is gonna be the biggest headache I will ever have. thinking about it, it's just like a lot. And this is like the general configuration. A lot. I gotta make these schemas. Not even using a query client. I don't believe I am. Oh, I am. No. Oh, where is this being analyzed? Nowhere. Because it's not being used as a fetcher. I don't need the fetcher, I just need the API call. So, I had to get rid of the overarching utilization of X, of G, and articles in G. That's a lot more. Yep, basically it. Count it up, count it up, count it up, count it, count it up, count it up, count it up, count it. Okay, so the other elephant in the room would be this thing. Providers, these two. I gotta like move them around, and it's like I'm using item effect too, so I'm cooked. Holy type safety, Batman! Oh my god. It's possible to find obviously other places. It's possible to define in which plus item are defined. Find PID equals active marker, in which find place item, find, of which doesn't equal and boolean, filter boolean. Filter is not null. Filter, boolean, oh, my bad. Where might, fine, and then I just gotta filter the entire thing. Active place, because it can't be guaranteed. Active marker equals active marker string. Fine, places to display. Then what if it's null? deprecated. Deprecated declarations marked as deprecated here. Access a calling market away input of vehicle C deprecated. As of 2024, please use markers advanced mark element, Google Maps, marker advanced marker element, marker advanced marker element. It does have a Z index. just gonna compromise. Truly. This revamp is gonna be the literal anyways, let's see. It's a lot to actually revamp this. I have to do a bunch of things. What was it before? Let's see. New Google Maps marker. Hold on. It's pretty expensive. This is marker options. This was marker max Z index. Static only Z index. It was max Z index. Yeah, it's about the same. Only difference is whatever this is. over here. Dun, dun, which is totally fine. pretty cool. Let's put this on pause. No, never mind. I just put it through. Yeah. go take a break.
I think as these walls go up, we're going to very rapidly see a lot of people get VPN pilled, as it were, because they're not going to have any other option.
We've talked a lot on Free Speech Friday about the massive amount of personal data that travels across the internet and through your phone every single second. Safeguarding your privacy online is so important. So today I want to dig into the world of VPNs. A VPN, or virtual private network, basically works by encrypting your internet connection and masking your IP address, which makes it harder for hackers, corporations, and even governments to track your activity online. Most people know VPNs as a way to get around geogating. So if your content is banned in one country, you can use a VPN to get around that ban and access the internet basically as if you were in another country. Unfortunately, as authoritarian governments in places like America and the UK and elsewhere seek to crack down on online speech, VPNs are under attack. It's getting harder and harder to use them effectively, and recently there's been talk of even an outright ban on VPNs. Leah Holland is an activist at Fight for the Future, a civil liberties group fighting to protect VPN access. Today, we're going to dig into the political campaign against VPNs. We're going to talk about how to fight back, why you should use them, when you should use them, and more. Hi, Leah. Welcome.
Hi, Taylor. I am such a fan of the pod. It's great to be here.
I'm so excited to talk to you today because I feel like we all hear about VPNs. Maybe some people that are listening have used them. When the TikTok ban went through for like 6 hours or whatever that was in January, I know a lot of people were sort of rushing to VPNs to see if they could use it to get around the TikTok ban. So I want to kind of back up and explain, I guess, like, what is a VPN? Like, how does it work?
So a VPN is essentially a secure tunnel to a different server to allow your web traffic to appear as if it's coming from somewhere else. That's the 10,000 foot view. It basically lets you pretend like you're browsing from a different location. So like, for example, if you're in Mississippi, you can pretend like you're browsing from New York and still be able to get on Blue Sky.
How did this industry emerge? Because I feel like now we hear about so many different VPNs. There's so many different options. How did VPNs originate?
VPNs started when the internet started to be a place to do work, when businesses decided that they were going to store all of their records and information online. They needed a solution to allow remote workers or like workers who are traveling or even just offices in different places to all be accessing and working off of the same documents. This is like early 2000s that we're talking. So the VPN was created more as like a corporate security solution than necessarily as a privacy or anti-censorship measure.
It seems like VPNs have now become sort of popular consumer technology? Like, I know so many VPN companies that advertise with YouTubers and stuff like that. When did it jump from being this like corporate security solution to this consumer tech product?
The jump there really began when people were getting those like nasty grams for torrenting music and movies and things like that. Also in the 2000s, where your IP address was used to identify you if you were downloading a show or an album or what have you, and threaten you with legal action from like IP holders. Because of the highly covered instances of trying to sue a teenager for downloading an album that they couldn't afford because it was $17 or whatever. And then additionally at that time, people became very aware of this privacy issue and started using VPNs for more than just torrenting.
So why should we care about VPNs now? Because I feel like people are like, okay, VPNs, yeah, I've heard of it. I see those sometimes. I get ads for them. Who cares?
VPNs are important because we live under surveillance capitalism and at a time when governments increasingly are wanting to censor the internet in order to take away its power, both as an educational tool and also as an organizing tool. The surveillance capitalist piece comes in when you think about VPNs blocking your IP address from being shared with whoever a website wants to give it to. And this is largely data brokers or really anybody who wants to pay for it. These websites are often trying to gobble up as much information as possible, and they use your IP address not only to tell people more or less exactly where you are, but potentially also to de-anonymize other information or other browsing activity that you do where you may not be sharing your name or other identifying information. So that IP address is actually a big linchpin in terms of surveilling you online. And that piece that we spoke about earlier about how a VPN allows you to pretend that you're browsing from somewhere else is very important when we have states like Mississippi where they have passed age verification legislation that is forcing websites to go dark in those regions in order not to be sued out of existence, or like with what we just saw in Nepal with the social media bans and VPN use spiking over there. This is a way to get to the internet that the government doesn't want you to have, and it is one of our last-ditch tools to do so.
So that's what I kind of want to get into, because I feel like exactly what you just said of this is sort of this last-ditch tool that people have to circumvent some of these really restrictive like censorship laws. I know in the UK, after the Online Safety Act passed, VPN usage spiked, and since then there's talk of like banning VPNs, I think, and also trying to make it so that you can't use VPNs. Like even with the TikTok ban, when it did go into effect, I think that you couldn't even use a VPN to circumvent it. So it seems like VPNs are under attack.
Yeah, they are, because for a lot of people, they are that last-ditch tool either for their privacy and safety online or for online access to knowledge and information. But a crucial thing to note to make this like not a VPN ad is that VPNs are filtering your web traffic. So instead of that website or what have you catching everything that you do online, the VPN is catching it, which makes it very, very important for the VPN that you're using to be trustworthy, which can sometimes be a really hard thing to assess, because if it's some free VPN you found online and you just decided to install randomly, they could have your credit card info, your banking login, all of the above, because they're the ones that are holding those keys to your traffic and your online life. So it's in no way a perfect system, and it's not the system that we should have in order to just use the internet the way that we want to, but it is important because we live under 19th century privacy laws and in a time of great moral panic around online safety that's turning out to be a force for making the internet even less safe than it was before.
Let's talk about some of these bans. Like, how can they ban VPNs if, you know, the VPN is making it seem like you're not even based where you're based?
The easiest and like most low-hanging fruit way to ban VPNs is to ban them from the App Store for Apple. And a lot of people previously have said, okay, well, they're banned from Apple's App Store, so I'll just use an Android. But now Google is about to require that all apps be registered with Google. So it's creating a very similar choke point for the like base level ability to install or sideload a VPN on your phone or like other devices. So that's like the base level way to do this. And then in a country like Indonesia, for example, I was reading about all these different ways where VPNs are largely banned, that people are increasingly finding alternative means to install VPNs. And this is everything from like NGOs handing out thumb drives with VPN tech on them so that people can install the technology to just private hand-to-hand transmission of the files that you would need to install these pieces. And when you get to that point where the government is engaging in like more and more sophisticated bans on VPNs, what it is the really like it's a cat and mouse game between the government that is trying to identify traffic that is encrypted that could be a VPN and the creators of the VPN who are trying to out-innovate those sensors that are looking to like target and shut down those operations.
I know I sound like a crazy person every week ranting about it, like, oh my God, we're getting censorship around the world. But like, there are these sort of like global trends around these censorship laws and sort of just creating, honestly, the type of internet that we've always criticized countries like China and Russia for having, where it's like a completely kind of domestic version of the internet where you only can access information that's approved. You can only access approved websites. And we're kind of losing like the global nature of the web. And it feels like in a lot of ways, like VPNs are kind of the last line of defense in that like effort to kind of maintain this globalized system.
It's sad but true that we haven't gotten to a point where we understand that the tools of censorship in the hands of people that we don't like is always going to make us feel bad. You know, just like the simple math here in the U.S., for example, if you create a tool to tamp down on the speech of those you don't agree with, that ultimately that tool will be turned against you when the political tides change. And that's why, you know, the First Amendment is so valuable and why we've been able to have these incredible freedoms and these incredible technologies here in the U.S. is that we just haven't quite totally completely lost that yet, but we are here teetering on the cusp and hoping that these ignorant politicians who are leveraging the moral panic about kids' online safety for political points will wake up in time to not completely destroy like one of the greatest things that we've ever built, which is the internet.
Yeah, that's really bleak. I mean, I think a lot of people in America too, it's like you see things, you're talking about Indonesia or Nepal or these other countries or even Europe, and you're like, well, that could never happen here.
It's funny because we can like point to Russia. There's like 200 VPNs banned from the App Store there. China has the Great Firewall. And I think that 6 months ago, a lot of people in the UK were thinking that exact thing, where they were thinking that this could never happen here. We wouldn't cause everybody to have to give their ID or their biometrics up in order to use the internet. And wham bam, there it is. That is the lived reality of everybody in Britain who isn't using a VPN right now, which is just wild. And we've been on the cusp here in the US for years of passing legislation that would do that exact same thing. Like, it's not quite a coincidence to me in my head that like it's UCOSA that passed and is causing this in Britain, and it's COSA here in the US that is one of the main laws that would become a vehicle for this sort of ID check regime and the trickle down of, well, if everybody doesn't want to do ID checks, what are they going to do? They're going to use VPNs. What are politicians going to go after next? What's the next boogeyman? VPNs.
So how do you decide like what's a good VPN and what's not? Because I feel like there's so many sort of scammy VPNs, and you just mentioned like a lot of them also harvest data or like overcharge you, or like you're locked into some scheme where you're charged every month forever now, or like what are the good ones to buy, or like what should people look out for if they do want to get a VPN? And when do you think people should consider getting a VPN? Like, is this something that we should all have on our phone right now?
I think it's important to think about this the same way that we think about using any other privacy tool like Signal, and that the more people use it, the more it becomes normalized, the more it's a clapback against the forces of surveillance capitalism. And yeah, it is a safety tool. It is a tool to not tell people exactly where you are all the time, which I think is pretty great. But you do have to be careful. The VPNs that are trustworthy are kind of hard to pick out from the sea of other choices. The thing that I would recommend the most, that is the best resource that I found, is in the Electronic Frontier Foundation's Surveillance Self-Defense Guide. They have a whole article on how to choose VPNs, how to think about things like whether or not the VPN can actually access and see your traffic, whether they keep logs of where you go, who they're owned by, those sorts of pieces, because it can change depending on the shift in ownership or shift in priorities or shift in privacy policy of the VPN, or what laws they have to comply with in the country that they operate in. So there's a lot of factors to go in there, and you really just have to be an active thinker in terms of who you're trusting to filter your entire online life through their servers to hide it from all the people that we know are not there with good intentions.
I feel like it's just like a devil's bargain where it's like, well, do you want this probably potentially terrible entity to have all of your data, or do you want this definitely terrible entity to have all of your data?
At Fight for the Future, because we've been working on de-Googling and getting off of big tech platforms in terms of our day-to-day operations, we actually use that old school method of having it all on a server and then using a VPN to securely operate at Fight for the Future. So that's been really interesting to think about also in terms of VPNs, is what happens to businesses that are increasingly relying once again on their own servers and on technology that they control if these VPNs are banned.
Yeah, no, that totally makes sense. And it's funny that like this thing that started as this business solution is now maybe looping back again to be this thing that businesses and people all rely on.
One example here is that we just had two folks go to a conference in Portugal, and while they were there, while they deleted all of the info off of their phones and devices and what have you when they were doing border crossings, they could log on to our VPN and remotely access all of our tech tools. And if that conference had been in Britain, they would have been able to browse the internet as if they were in Chicago or wherever, because the VPN was operating from that location. It's actually incredibly important to us to have the ability to do that sort of secure operation.
I mean, you were saying earlier that it's helpful for VPN use to be normalized and for regular people to use it. So that way, if they do, or when they do try to ban it, it's much harder. And I am trying to think like what that would take. Like, what do you think people could do to normalize the use a little bit more? Because I feel like aside from advertising, which all these VPN companies do all the time, it still just doesn't feel necessary day to day, I think, to most people.
For a lot of people, I think it's becoming increasingly necessary. A lot of it is just a barrier of education and awareness of how our location data is being used, which may be to an extent generational, where I know that there are a lot of younger folks who are very aware all the time that their phone is tracking where they are. And it seems, though, that in terms of mass mobilization and really getting people to pay attention and to advocate for these last-ditch tools for the internet that we all want to have, is you start taking things away from them. I think it's like 25 different states have passed various age check porn bans or what have you now. And I believe that that's pretty motivating. Even thinking back to the example of Nepal just recently, again, there was one VPN provider that said their usage had spiked 8,000% in just a couple of days when Nepal cut off access to social media. I think as these walls go up, we're going to very rapidly see a lot of people get VPN pilled, as it were, because they're not going to have any other option. And that's going to become pretty easy to organize around, I hope, at least, because people are going to fight for the internet that they want.
Well, so what are you guys doing to fight for VPNs? Because I know you guys have like a campaign kind of going and you're trying to raise awareness. So, you know, for people that do want to get a little bit more involved, aside from just using it themselves, like what sort of campaign are you guys launching to protect access to this technology?
So this is pretty nihilistic, but one of our base analyses of politicians is that you just have to make doing the bad thing scarier than not doing anything at all. And so for VPN bans, we are organizing to try and make some noise to preclude that thought process when lawmakers look at VPN use and think, oh, well, let's just ban that. On September 25th, we just did this huge day of action where we had folks call their lawmakers, did this petition signing and social media posts and work with influencers and all of the above to really raise awareness of the threat against VPNs and also why they're so important. I am so excited for everything that we were able to accomplish on that day and still have going actually at defendvpns.com. We have tools to contact lawmakers that are up there, really easy call tools that make it a no-brainer to get in contact with all of your representatives if you're here in the US. And we also have a petition that folks can sign, and we're planning to do more. And if you sign that petition, you'll be signed up to know when we next take action.
Awesome. Well, excited to go to defendvpns.com.
Defendvpns.com.
Leah, well, thank you so much for chatting with me today. And thank you so much for all of the work that you're doing to protect a free and open internet.
It's been such a pleasure, Taylor. Thanks so much for having me.
All right, that's it for this week's episode of Free Speech Friday. If you like the show, please support me on Patreon, where you can get bonus episodes and more. The link is in the description below. You can also subscribe to my tech and online culture newsletter, usermag.co. That's usermag.co, where I write about all of these issues and more. If you like this show and you're listening to me on a podcast platform, please give me a rating and review on Apple Podcasts, Spotify, or wherever you listen. I'll be back next week with a brand new episode of Free Speech Friday. See you then.
Okay, I'm back. Hope you enjoyed that little tidbit. What is this? Oh.
How many times do you need to shuffle a deck of cards?
This is next if I ever do. I want to take like a longer break. Anyways, yeah, I just realized that I have to do a lot of things, but thanks to modularity, it's less, I guess, than what I thought it'd be. But I don't know any lines of code I've changed or modified, but it's likely a lot. Okay, so let's just see the insides. 15,000, like 7,000. In the past week or so. That's the month. Still 7,000. Like 8,000. So yeah. It's not that much. 622. This is like around New York, East Coast. Okay, so let's just run. I did run again. Or did I? I'm not sure. Let's just have the timestamps. Okay, anyway, so the only thing I have to do now is rearrange these, and so we have here is what we have here is okay. So what we have here is providers, what provider? Gotta merge these. Alright. There's something else, but I'm not gonna use effect add-on. That's overkill. I'm gonna use it on another product, that's for sure. But not this one, because that's a lot. That's a headache. That's an actual headache. This doesn't work. Programmatically or logically. So let's just. I'm gonna do something really. I gotta do something really quickly. So yeah. not sure the difference. Not sure. I mean, not sure the difference between anyways. It's not too long. It should have worked properly. It depends on the Python version I'm using, so. Whatever. just use sad. Or JQ. But I should practice with the last one. Like, I should practice with sad and JQ, like, a bit more. Basically 3 projects. Not very much. Yeah, it's not like everything. Yeah, it's not like everything. So, oh boy. That's the reason why. Yeah, that's the reason why. Anyways. Oh boy. This is like peak OCD. It doesn't get any better. Okay, let's see. Okay, cool. That's cool, that's cool, that's cool. Gotta do something really quickly. Alright, cool. Fix the sources. That's how you do that. This needs to be changed, this needs to be changed. Green needs to be changed. Why am I taking it? That's funny. So, I feel like it should be though. Oh, see what? Anyway, how long has it been? I don't know. But how do I do this dynamically? That's gonna be a feat in and of itself. It's gonna be a feat in and of itself. Okay, so what page? Again, the Juliet. Images. Now, the other thing I have to do, how do I dynamically load accepted dubs and calculate exhausted dubs? I don't know. Like, I don't know any, like, package that would do that for me. If you're wondering if I ever sleep, I do. But there are times when I just don't sleep. Like, I'm trying to force myself to sleep like 4 hours again. Just 'cause it's like more convenient for me to get a lot more done. Anyways, break, 5-minute break, and yeah. I promised that Veritas video with markup chains.
Cards to make them truly random. How much uranium does it take to build a nuclear bomb? How can you predict the next word in a sentence? And how does Google know which page you're actually searching for? Well, the reason we know the answer to all of these questions is because of a strange math feud in Russia that took place over 100 years ago. In 1905, socialist groups all across Russia rose up against the Tsar, the ruler of the empire. They demanded a complete political reform, or failing that he step down from power entirely.
This divided the nation into two. So on one side, you got the Tsarists, right? They wanted to defend the status quo and keep the Tsar in power. But then on the other side, you had the socialists who wanted this complete political reform. And this division was so bad that it crept into every part of society, to the point where even mathematicians started picking sides.
On the side of the Tsar was Pavel Nekrasov, unofficially called the Tsar of Probability. Nekrasov was a deeply religious and powerful man, and he used his status to argue that math could be used to explain free will and the will of God.
His intellectual nemesis on the socialist side was Andrei Markov, also known as Andrei the Furious. Markov was an atheist, and he had no patience for people who were being unrigorous, something he considered Nekrasov to be, because in his eyes, math had nothing to do with free will or religion. So he publicly criticized Nekrasov's work, listing it among the abuses of mathematics. Their feud centered on the main idea people had used to do probability for the last 200 years. And we can illustrate this with a simple coin flip. When I flip the coin 10 times, I get 6 times heads and 4 times tails, which is obviously not the 50-50 you'd expect. But if I keep flipping the coin, then at first the ratio jumps all over the place. But after a large number of flips, we see that it slowly settles down and approaches 50-50. And in this case, after 100 flips, we end up on 51 heads and 49 tails, which is almost exactly what you would expect. This behavior, that the average outcome gets closer and closer to the expected value as you run more and more independent trials, is known as the law of large numbers. It was first proven by Jacob Bernoulli in 1713, and it was the key concept at the heart of probability theory right up until Markov and Nekrasov. But Bernoulli only proved that it worked for independent events, like a fair coin flip, or when you ask people to guess how much they think an item is worth, where one event doesn't influence the others. But now imagine that instead of asking each person to submit their guess individually, you ask people to shout out their answer in public. Well, in this case, the first person might think it's an extraordinarily valuable item and say it's worth around $2,000. But now all the other people in the room are influenced by this value, and so their guesses have become dependent. And now the average doesn't converge to the true value, but instead it clusters around a higher amount.
And so for 200 years, probability had relied on this key assumption that you need independence to observe the law of large numbers. And this was the idea that sparked Nekrasov and Markov's feud. See, Nekrasov agreed with Bernoulli that you need independence to get the law of large numbers. But he took it one step further. He said, if you see the law of large numbers, you can infer that the underlying events must be independent.
Take this table of Belgian marriages from 1841 to 1845. Now you see that every year the average is about 29,000. And so it seems like the values converge and therefore that they follow the law of large numbers. And when Nekrasov looked at other social statistics like crime rates and birth rates, he noticed a similar pattern. But now think about where all this data is coming from. It's coming from decisions to get married, decisions to commit crimes, and decisions to have babies, at least for the most part. So Nekrasov reasoned that because these statistics follow the law of large numbers, the decisions causing them must be independent. In other words, he argued that they must be acts of free will. So to him, free will wasn't just something philosophical. It was something you could measure. It was scientific.
But to Markov, Nekrasov was delusional. He thought it was absurd to link mathematical independence to free will. So Markov set out to prove that dependent events could also follow the law of large numbers, and that you can still do probability with dependent events.
To do this, he needed something where one event clearly depended on what came before. And he got the idea that this is what happens in text. Whether your next letter is a consonant or a vowel depends heavily on what the current letter is. So to test this, Markov turned to a poem at the heart of Russian literature, Eugene Onegin by Alexander Pushkin.
He took the first 20,000 letters of the poem, stripped out all punctuation and spaces, and pushed them together into one long string of characters. He counted the letters and found that 43% were vowels and 57% were consonants. Then Markov broke the string into overlapping pairs. That gave him 4 possible combinations: vowel-vowel, consonant-consonant, vowel-consonant, or consonant-vowel. Now, if the letters were independent, the probability of a vowel-vowel pair would just be the probability of a vowel twice, which is about 0.18, or an 18% chance. But when Markov actually counted, he found vowel-vowel pairs only show up 6% of the time, way less than if they were independent. And when he checked the other pairs, he found that all actual values differed greatly from what the independent case would predict. So Markov had shown that the letters were dependent.
To beat Nekrasov, all he needed to do now is show that these letters still followed the law of large numbers. So he created a prediction machine of sorts.
He started by drawing two circles, one for a vowel and one for a consonant. These were his states. Now, say you're at a vowel, then the next letter could either be a vowel or a consonant. So he drew two arrows to represent these transitions. But what are these transition probabilities? Well, Markov knew that if you pick a random starting point, there is a 43% chance that it'll be a vowel. He also knew that vowel-vowel pairs occur about 6% of the time. So to find the probability of going from a vowel to another vowel, he divided 0.06 by 0.43 to find a transition probability of about 13%. And since there is a 100% chance that another letter comes next, all the arrows going from the same state need to add up to 1. So the chance of going to a consonant is 1 minus 0.13, or 87%. He repeated this process for the consonants to complete his predictive machine. So let's see how it works. We'll start at a vowel. Next, we generate a random number between 0 and 1. If it's below 0.13, we get another vowel. If it's above, we get a consonant. We got 0.78, so we get a consonant. Then we generate another number and check if it's above or below 0.67, 0.21, so we get a vowel. Now, we can keep doing this and keep track of the ratio of vowels to consonants. At first, the ratio jumps all over the place, but after a while, it converges to a steady value, 43% vowels and 57% consonants, the exact split Markov had counted by hand.
So Markov had built a dependent system, a literal chain of events, and he showed that it still followed the law of large numbers, which meant that observing convergence in social statistics didn't prove that the underlying decisions were independent. In other words, those statistics don't prove free will at all. Markov had shattered Nekrasov's argument, and he knew it. So he ended his paper with one final dig at his rival. Thus, free will is not necessary to do probability. In fact, independence isn't even necessary to do probability. With this Markov chain, as it came to be known, he found a way to do probability with dependent events. This should have been a huge breakthrough, because in the real world, almost everything is dependent on something else. I mean, the weather tomorrow depends on the conditions today. How a disease spreads depends on who's infected right now, and the behavior of particles depends on the behavior of particles around them. Many of these processes could be modeled using Markov chains.
Did people think it was like a mic drop moment, like, oh, Nekrasov is out, like Markov's a man? Or people didn't really notice, or it was obscure, or...
I feel like people didn't really notice. Like, it wasn't a really big thing. And Markov himself seemingly didn't care much about how it might be applied to practical events. He wrote, "I am concerned only with questions of pure analysis. I refer to the question of the applicability with indifference." Little did he know that this new form of probability theory would soon play a major role in one of the most important developments of the 20th century. On the morning of the 16th of July, 1945, the United States detonated the Gadget, the world's first nuclear bomb. The 6-kilogram plutonium bomb created an explosion that was equivalent to nearly 25,000 tons of TNT. This was the culmination of the top-secret Manhattan Project, a 3-year-long effort by some of the smartest people alive, including people like J. Robert Oppenheimer, John von Neumann, and a little-known mathematician named Stanislav Ulam.
Even after the war ended, Ulam continued trying to figure out how neutrons behave inside a nuclear bomb. Now, a nuclear bomb works something like this. Say you have a core of uranium-235. Then when a neutron hits a U-235 nucleus, the nucleus splits, releasing energy and, crucially, 2 or 3 more neutrons. If, on average, those new neutrons go on to hit and split more than one other U-235 nucleus, you get a runaway chain reaction, so you have a nuclear bomb. But uranium-235, the fissile fuel needed for the bombs, was really hard to get. So one of the key questions was, just how much of it do you need to build a bomb? And this is why Ulam wanted to understand how the neutrons behave.
But then, in January of 1946, everything came to a halt. Ulam was struck by a sudden and severe case of encephalitis, an inflammation of the brain that nearly killed him. His recovery was long and slow, with Ulam spending most of his time in bed. To pass the time, he played a simple card game, Solitaire. But as he played countless games, winning some, losing others, one question kept nagging at him. What are the chances that a randomly shuffled game of Solitaire could be won? It was a deceivingly difficult problem to solve. Ulam played with all 52 cards, where each arrangement created a unique game, so the total number of possible games was 52 factorial, or about 8 times 10 to the 67. So solving this analytically was hopeless. But then Ulam had a flash of insight. What if I just play hundreds of games and count how many could be won? That would give him some sort of statistical approximation of the answer. Back at Los Alamos, the remaining scientists grappled with much harder problems than Solitaire, like figuring out how neutrons behave inside a nuclear core. In a nuclear core, there are trillions and trillions of neutrons all interacting with their surroundings. So the number of possible outcomes is immense, and computing it directly seemed impossible.
But when Ulam returned to work, he had a sudden revelation. What if we could simulate these systems by generating lots of random outcomes, like I did with Solitaire? He shared this idea with von Neumann, who immediately recognized its power, but also spotted a key problem.
See, in Solitaire, each game is independent. How the cards are dealt in one game have no effect on the next. But neutrons aren't like that. A neutron's behavior depends on where it is and what it has done before. So you couldn't just sample random outcomes like in Solitaire. Instead, you needed to model a whole chain of events, where each step influenced the next. What von Neumann realized is that you needed a Markov chain. So they made one, and a much simplified version of it works something like this. Now, the starting state is just a neutron traveling through the core. And from there, 3 things can happen. It can scatter off an atom and keep traveling, so that gives you an arrow going back to itself. It can leave the system or get absorbed by a non-fissile material, in which case it no longer takes part in the chain reaction, and so it ends its Markov chain. Or it can strike another uranium-235 atom, triggering a fission event and releasing 2 or 3 more neutrons that then start their own chains. But in this chain, the transition probabilities aren't fixed. They depend on things like the neutron's position, velocity, and energy, as well as the overall configuration and mass of uranium. So a fast-moving neutron might have a 30% chance to scatter, 50% chance to be absorbed or leave, and a 20% chance to cause fission. But a slower-moving neutron would have different probabilities. Next, they ran this chain on the world's first electronic computer, the ENIAC. The computer started by randomly generating a neutron starting conditions and stepped through the chain to keep track of how many neutrons were produced on average per run, known as the multiplication factor K. So, if on average 1 neutron produces another 2 neutrons, then K is equal to 2. And if on average every 2 neutrons produce 3 neutrons, then K is equal to 3 over 2, and so on. Then, after stepping through the full chain for a specified number of steps, we collect the average K value and record that number in a histogram. This process was then repeated hundreds of times, and the results tallied up, giving you a statistical distribution of the outcome. If you find that in most cases K is less than 1, the reaction dies down. If it's equal to 1, there's a self-sustaining chain reaction, but it doesn't grow. And if K is larger than 1, the reaction grows exponentially, and you've got a bomb.
With it, von Neumann and Ulam had a statistical way to figure out how many neutrons were produced without having to do any exact calculations. In other words, they could approximate differential equations that were too hard to solve analytically.
All that was needed was a name for the new method. Now, Ulam's uncle was a gambler, and the random sampling and high stakes reminded Ulam of the Monte Carlo casino in Monaco, and the name stuck. The Monte Carlo method was born. The method was so successful that it didn't stay secret for long. By the end of 1948, scientists at another lab, Argonne in Chicago, used it to study nuclear reactor designs. And from there, the idea spread quickly.
Ulam later remarked, "It is still an unending source of surprise for me to see how a few scribbles on a blackboard could change the course of human affairs."
And it wouldn't be the last time a Markov chain-based method changed the course of human affairs.
In 1993, the internet was open to the public, and soon it exploded. By the mid-1990s, thousands of new pages appeared every day, and that number was only growing. This created a new kind of problem. I mean, how do you find anything in this ever-expanding sea of information? In 1994, two Stanford PhD students, Jerry Young and David Philo, founded the search engine Yahoo to address this issue. But they needed money. So a year later, they arranged to meet with Japanese billionaire Masayoshi Son, also known as the Bill Gates of Japan.
They were looking to raise $5 million for their new startup. But Sun has other plans. He offers to invest a full $100 million instead. That's 20 times more than what the founders asked for. So Jerry Yang declines, saying, "We don't need that much." But Sun disagrees. "Jerry, everyone needs $100 million. Before the founders get a chance to respond, Sun jumps in again and asks, "Who are your biggest competitors?" "Excite and Lycos," the pair respond. Sun orders his associate to write those names down, and then he says, "If you don't let me invest in Yahoo, I will invest in one of them, and I'll kill you." See, Sun had realized something. None of the leading search engines at the time had any superior technology. They didn't have a technological advantage over the others. They all just ranked pages by how often a search term appears on a given page.
So the battle for the #1 search engine would be decided by who could attract the most users, who could spend the most on marketing.
Lycos, go get it. Get Lycos, or get lost.
This is revolution.
And marketing required a lot of money. Money that Sun had, so he could decide who won the war. Yahoo's founders realized they were left with no real choice but to accept Sun's investment.
So here we are right in the middle of Yahoo.
And within 4 years, Yahoo became the most popular site on the planet.
In the time it takes to say this sentence, Yahoo will answer 79,000 information requests worldwide. The two men are now worth $120 million each.
But Yahoo had a critical weakness.
See, Yahoo's keyword search was easy to trick. To get your page ranked highly, you could just repeat keywords hundreds of times, hidden with white text on a white background.
One thing they didn't have in those early days was a notion of quality of the result. So they had a notion of relevance, saying, does this document talk about the thing that you're interested in? But there wasn't really a notion of which ones are better.
What they really needed was a way to rank pages by both relevance and quality. But how do you measure the quality of a web page? Well, to understand that, we need to borrow an idea from libraries.
So I'm old enough that library books used to have a paper card in it that was a stamp of all the due dates of when it was due back. You took a book, and if it had a lot of those, you said, oh, this is probably a good book. And if it didn't have any, you said, well, maybe this isn't the best book.
Stamps acted like endorsements. The more stamps, the better the book must be. And the same idea can be applied to the web. Over at Stanford, two PhD students, Sergey Brin and Larry Page, were working on this exact problem. Brin and Page realized that each link to a page can be thought of as an endorsement. And the more links a page sends out, the less valuable each vote becomes. So what they realized is that we can model the web as a Markov chain.
To see how this works, imagine a toy internet with just 4 web pages. Call them Amy, Ben, Chris, and Dan. These are our states. Typically, one web page links to others, allowing you to move between them. These are our transitions. In this setup, Amy only links to Ben, so there's a 100% chance of going from Amy to Ben. Ben links to Amy, Chris, and Dan, so there's a 33% chance of going to any of those pages, and we can fill out the other transition probabilities in the same way. So now we can run this Markov chain and see what happens. Imagine you're a surfer on this web. You start on a random page, say Amy, and you keep running the machine and keep track of the percentage of time you spend on each page. Over time, the ratio settles, and the scores give us some measure of the relative importance of these pages. You spend the most time on Ben, so Ben is ranked first, followed by Amy, then Dan, and lastly Chris. It might seem like there's an easy way to beat the system, just make 100 pages all linking to your website. Now you get 100 full votes and you'll always rank on top. But that is not the case. While during the first few steps they might make your page seem important, none of the other websites link to them. So over many steps, their contributions don't matter. You might have many links, but they're not quality links, so they don't affect the algorithm.
But there is still one problem though. Not all pages are connected. In networks like this one, a random server can get stuck in a loop, never reaching the rest of the web. So to fix this, we can set a rule that 85% of the time, our random server just follows a link like normal. But then for about 15% of the time, they just jump to a page at random. This damping factor makes sure that we explore all possible parts of the web without ever getting stuck. By using Markov chains, Page and Brin had built a better search engine, and they called it PageRank.
Because it's talking about how pages web pages react with each other, and also because the founder's name is Larry Page, so he snuck that in.
With PageRank, they got much better search results, often getting you to the site you were looking for in one go. Although to some, this sounded like a terrible idea.
Others said, oh, well, you're telling me you get a search that will get the right result on the first answer? Well, I don't want that, because if it takes them 3 or 4 searches to get the right answer, then I have 3 or 4 chances to show ads. And if you get them the answer right away, I'm just going to lose them. So, I don't see why better search is better.
But Page and Brin disagreed. They were convinced that if their product was far superior, then people would flock to it.
I would say it actually is a democracy that works. If all pages were equal, anybody can manufacture as many pages as they want. I can set up 1 billion pages on my server tomorrow. We shouldn't treat them all as equal.
Just looking at the data out of curiosity, we found that we had technology to do a better job of search, and we realized how impactful having great search can be.
And so, in 1998, they launched their new search engine to take on Yahoo. Initially, they called it Backrub after the backlinks it analyzed. But then they realized that maybe that's not the most attractive name. Now, their ambitions were big, to essentially index all the pages on the internet, and they needed a name equally as big. So they thought of the largest number they could think of, 10 to the power 100, a Google. But then, when trying to register their domain, they accidentally misspelled it, and so Google was born. Over the next 4 years, Google overthrew Yahoo to become the most used search engine.
Everyone who knows the internet almost certainly knows Google.
Googling is like oxygen to teenagers.
And today, Alphabet, which is Google's parent company, is worth around $2 trillion.
When Google makes even the slightest change in its algorithms, it can have huge effects.
Google.
They're on fire, and the reason why they're on fire is because they're focused. And they're more focused than Yahoo, who does search. They're more focused than Microsoft, who does search with Bing. Yahoo has lots of traffic. They always have. They have some really great properties. But I don't think Yahoo is the go-to place, you know?
And at the heart of this trillion-dollar algorithm is a Markov chain, which only looks at the current state to predict what's going to happen next. But in the 1940s, Claude Shannon, the father of information theory, started asking a different question. He went back to Markov's original idea of predicting text, but instead of just using vowels and consonants, he focused on individual letters. And he wondered, what if instead of looking at only the last letter as a predictor, I look at the last 2? Well, with that he got text that looked like this. Now, it doesn't make much sense, but there are some recognizable words, like way, off, and D. But Shannon was convinced he could do better. So next, instead of looking at letters, he wondered, what if I use entire words as predictors? That gave him sentences like this. The head and in frontal attack on an English writer that the character of this point is therefore another method for the letters that the time of whoever told the problem for an unexpected. Now, clearly this doesn't make any sense. But Shannon did notice that sequences of 4 words or so generally did make sense. For instance, attack on an English writer kind of makes sense. So Shannon learned that you can make better and better predictions about what the next word is going to be by taking into account more and more of the previous words. It's kind of like what Gmail does when it predicts what you're going to type next. And this is no coincidence. The algorithms that make these predictions are based on Markov chains.
They're not necessarily using letters. They use what they call tokens, some of which are letters, some of which are words, marks of punctuation, whatever. So it's a bigger set than just the alphabet. The game is simply, we have this string of tokens that, might be 30 long, and we're asking, what are the odds that the next token is this or this or this?
But today's large language models don't treat all those tokens equally. Because unlike simple Markov chains, they also use something called attention, which tells the model what to pay attention to. So in the phrase, the structure of the cell, the model can use previous context like blood and mitochondria to know the cell most likely refers to biology rather than a prison cell, and it uses that to tune its prediction. But as large language models become more widespread, one concern is that the text they produce ends up on the internet, and that becomes training data for future models.
When you start doing that, the game is very soon over. You come, in this case, to a very dull, stable state. It just says the same thing over and over and over again forever. The language models are vulnerable to this process.
And any system like this, where we have a feedback loop, will become hard to model using Markov chains.
Take global warming, for instance. As we increase the amount of carbon dioxide in the air, the average temperature of the Earth increases. But as the temperature increases, the atmosphere can hold more water vapor, which is an incredibly powerful greenhouse gas. And with more water vapor, the temperature increases further, allowing for even more water vapor. So you get this positive feedback loop, which makes it hard to predict what's going to happen next. So there are some systems where Markov chains don't work. But for many other dependent systems, they offer a way of doing probability.
But what's fascinating is that all these systems have extremely long histories. I mean, you could trace back all the letters in a text, trace back all the interactions of what a neutron did, or trace back the weather for weeks. But the beautiful thing Markov and others found is that for many of these systems, you can ignore almost all of that. You can just look at the current state and forget about the rest. That makes these systems memoryless. And it's this memoryless property that makes Markov chains so powerful. Because it's what allows you to take these extremely complex systems and simplify them a lot to still make meaningful predictions.
As one paper put it, problem solving is often a matter of cooking up an appropriate Markov chain.
It's kind of ridiculous to me that this basic fact of mathematics would come out of a fight like that, which, really had nothing to do with it. But all the evidence suggests that it really was this determination to show up Nekrasov that led Markov to do the work.
But there's one question we still haven't answered. When playing solitaire, how did Ulam know his cards were perfectly shuffled? I mean, how many shuffles does it take to get a completely random arrangement of cards?
If you have a deck of cards, you need to shuffle it, right?
Okay.
How often, if you're shuffling, like, you split it in half and then you do how often do you have to shuffle it to make it completely random?
2.
2?
Yeah, I'm going with 26.
4 times.
4 times.
I don't know. 52 times.
Okay. It's not a bad guess.
7?
It is 7.
Really?
Yeah.
So you can think of card shuffling as a Markov chain, where each deck arrangement is a state, and then each shuffle is a step. And so for a deck of 52 cards, if you riffle shuffle it 7 times, then every arrangement of the deck is about equally likely. So it's basically random.
But I can shuffle like that. So for me, what I do is I do it like this. How many times do you think you have to shuffle like this to get it random?
What do you think? And perhaps more importantly, how would you go about working it out? Well, that's where today's sponsor, Brilliant, comes in. Brilliant is a learning app that gets you hands-on with problems just like this. Whether it's math, physics, programming, or even AI, Brilliant's interactive lessons and challenges let you play your way to a sharper mind. You can discover how large language models actually work, from basic Markov chains to complex neural networks, or dig into the math behind this shuffling question. It's a fun way to build knowledge and skills that help you solve all kinds of problems, which brings us back to our shuffle. So, Casper, what actually is the answer?
It's actually over 2,000. Crazy, right?
Yeah.
So the next time someone offers to shuffle before a game, make sure they're doing it right. 7 riffles or it doesn't count. But the interesting part isn't just knowing that, it's understanding why and seeing how a simple question can lead you to some surprisingly complex mathematics. And that's what Brilliant is all about. So to try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/Veritasium. Click that link in the description or scan this handy QR code. And if you sign up, you'll also get 20% off their annual premium subscription. So I want to thank Brilliant for sponsoring this video, and I want to thank you for watching.
Easy.